Good day, everyone. My name is Taiwo Falana. I would like to talk about a particular topic we are all familiar with, and that is titration. So under volumetric analysis, we have titration of acid against a base. We have titration of acid against the trioxocarbonate, and also we have titration of oxidizing agents against the reducing agents. So titration is the ability or the process of determining the concentration of a solution by using a standard alkaline solution. So we can always determine the concentration of an acid solution by using the standard alkaline solution. The process is just a few process. Now, it is important we have all our apparatus in place, like the burettes, the pipettes, your base, then the acid, funnel, the beaker, the conical flask, and the Rhetor stand. Though we have more, we can include a white towel and then an indicator. A good example of an indicator is methyl orange to determine our endpoint. Now, the first thing is you pick up your burettes, then you slide the burettes in. Welcome back, everyone. I would like to make reference to the calculation we did the other time, and that is using iron sulfates, decahydrates, iron sulfates, heptahydrates to form our solution. So this is the practical aspect of it. Now I have my iron sulfate and I have my PMNO4, the potassium permanganate. As we all know, the potassium permanganate has this different characteristics of purple color. So while using it, we need to be extra careful so that we will not mess up the whole environment. And for the iron sulfates, it's kind of greenish in color. Now, the first thing, according to the question given, we are to weigh 5.5 grams of iron sulfate. But when you're using iron sulfates, the heptahydrates, then you take a measurement of 10.06 gram. So I would like to prepare just a small portion of iron sulfates. In order to do that, here I have the iron sulfate already measured, which is 2.52 gram. Then the next step is to pick up a beaker, pour the salt solution, the salt into the beaker in order to get the solution. In order to get the solution, we mix it up with 250 ml of water. 250 ml of water. Now, for the 250 ml, we'll try to make it up. Please, you need to be very careful in order to get the accurate results. So, you need to stir properly. And you can also use your stirring rod to mix properly. At times it takes time for it to dissolve, so it is important to just keep stirring. So this is 2.52 gram in 250 centimeter cube of the solution. And for this, we have the 1.58 gram in 1 dm cube of the solution. You can see this has been prepared. So we went through the same process. We undergo the same procedure by mixing the 1.58 gram gotten from this. We mix it up with 1 dm cube of water. Now, therefore, we can now go directly into our titration. Now, in order to carry out the titration, for redox titration, it is important to note that there is need for us to use the hydrogen tetrasulfate 6 acid. The hydrogen tetrasulfate 6 acid will be mixed up with iron sulfate in order to create an acidic solution. So we need to make this reducing agent slightly acidic. In order to determine the volume of base used, we need to get about 25 centimeter cube of iron sulfate. So you pipette 25 centimeter cube of iron sulfate from the main solution, from the 250 centimeter cube of iron sulfate prepared. So after getting the volume of base, or the volume of the reducing agent, which we all know, then you transfer to a conical flask gently. Mind you, regarding the acidic environment I said should be prepared alongside, we need tetrasulfate 6 acid. So we need about 5 mils of tetrasulfate 6 acid. To get the 5 mils, you can use a syringe, then measure up to 5 mils. Ensure you take accurate results to avoid error. And then you transfer to the iron sulfate solution in the conical flask. And please, this is 0.1 molar of H2SO4. This was actually gotten from the stock solution. Now, the conical flask, we have the iron sulfate. Then it's important to get a little portion of potassium permanganate that needs to be transferred into the burette. Now, for the potassium permanganate, is known to be cell. Now, back to what I actually explained. I said we have the KMNO4 here. So you're to pour into the burette. You pour gently.
Very nice.
You need to be careful while pouring. And there's something good about care menu 4. You take the upper radium and not the lower meniscus, the upper radius, which is highly important. Ensure you clean the environment or every part that looks dirty. Make sure it is up to the initial, which is 0. So now they're expected to titrate care menu 4 against FeSO4, which is iron sulfate. Now the color change should be pink, and you should be mindful of the burette readings where we have the endpoints. To obtain that, you can adjust your burette. If you notice it's very close to the conical flask, adjust it so that this will fit in. Then you start dropping gently. You observe it's giving a clear solution, so you continue dropping. You can take it out and stir. You need to be very careful. Mind you, you need to be very careful and notice the color change. So we have the color change, pink solution. So I don't need to go through the second and then the third one. We can always assume that our titer value ranges between 17 and 18. If it is if the solution is well prepared, and then the measurement, the amount of the mass you required is well taken, then we expect to get the actual endpoint at the appropriate range. Thank you for listening. Hello everyone. I'm talking about a topic known as redox titration. Redox titration is majorly the combination of oxidizing agents and reducing agents. And from the board, I'll try to make reference to the practical for this very year, the WAEC practical for this very year, which is year 2024. We have combination of two elements or compounds. Now we have the potassium permanganate and iron 2 sulfates. Potassium permanganate and iron 2 sulfates. This is the balance equation for the redox titration. This is the balance equation. We have the permanganate and then the iron with the product of the manganese and iron, and also the formation of water. During this process, it's important to know that potassium permanganate is the oxidizing agent and iron is the reducing agent. As we all know from the basis of redox reaction, oxidizing agents will undergo reduction, and that's why I have my line drawn from this side to this side. And why is it reduction? In oxidizing agents, in terms of the oxidation number, potassium permanganate 7 has oxidation number of +7. The manganate there has oxidation number of +7, and the manganate here is +2. So, in other words, we therefore have +2 reducing to +7 reducing to +2. On the other hand, we have iron, which is +2 here, iron 2 sulfate, undergoing oxidation. And why is it oxidation? There is increase in oxidation number from +2 to +3. So conversion of iron 2 to iron 3 is known as oxidation. We should not forget oxidizing agents end up being reduced. Reducing agents will become oxidized. Is an important information to follow. Now, for the practical given this very year, we have, since I mentioned iron sulfate and potassium permanganate, when they dissociate, especially when they're in ionic form, we have the formation of iron 2-. And for the oxidizing agents, potassium will dissociate, and also we have KMnO4, the MnO4-. Now, according to the question given, we've been given the numbers of gram that will mix up in 1 dm cube, and the potassium, the MnO4, we have to take a measurement of 1.58 gram. Now, the mass or the various masses we have to consider, they're highly important. You can achieve that by using a weighing balance, be it the automatic one or the weighing balance. Just make sure you take the right masses. Now, aside this, there's a way we can actually get the volume of acid that will be used. And this is the theoretical answer, or the theoretical part of it, not the practical, or not the titration itself. So please do not mix it up. Now, for the volume of acid used, in order to get it, we need to refer back to some of our basic chemistry. Now, from our basic chemistry, we have number of moles, which is known as mass over molar mass. The number of moles is measured in moles, the mass is in gram, and the molar mass is in gram per mole. Now, for the mass given, let's now take, for example, you want to get the number of moles of KMnO4, potassium permanganate. the mass given is 1.58, and the molar mass can be calculated from our basic chemistry. The potassium is 39, manganese is 54.9, and we have 16. Using your calculator, when you that will give 157.9. When you divide this, 1.58 divided by 157.9, that is equivalent to 0.01 moles. So it's a simple calculation. It's just like what we've done in our various classes. So do not forget, this is the molar mass. How to determine the molar mass of KMnO4. Back to our formula again. It is important to remember that number of moles in mole per dm cube is amount over the volume. And the volume you're referring to is in 1 dm cube, and this is in moles. So therefore, from the number of moles we got here, the moles, which is 0.01, in 1 dm cube, which is also 1000 centimeter cube. So that will still remain 0.01 mole per dm cube. I believe this is straightforward from our basic chemistry. So I'll rub off the board and then calculate the number of moles of iron sulfate that we're going to use. So determining the number of moles of iron sulfate, FeSO4, we still maintain the same formula, which is mass over the molar mass. From the mass given, like I mentioned, for this very year we are to focus on the mass of iron sulfate, which is 5.5, and the molar mass is 152 grams per mole, based on the molar mass calculated. Now, so therefore we have this to be 152. When you divide 5.5 divided by 152, this will give 0.0362 moles. So that shows the number of moles of iron sulfate that would react in the solution. Now, it is important to have it in dm cube. Therefore, refer back to this same formula. All I just need to do is erase this. We still have the same formula. So in 1 dm cube, which is also equivalent to 1000 centimeter cube, of the number of moles, which is 0.0362, is 0.0362. When you divide, it will still give you the same value, 0.0362 moles per dm cube of iron sulfate. There's another important information. At times, in order to get the iron sulfate is kind of hard or scarce in the market. So, most times, teachers are provided with iron 2 tetraoxosulfate, hexahydrate. This is visible, is common in the market. Now, when you have this type of salts, all you just need to do is, do one or two calculations, and then you still get the appropriate number of moles, and then you have a different mass. Now, to obtain that, we need to get the molar mass of iron 2 tetraoxosulfate 6 hexahydrate. The molar mass for this is, since iron 2 tetraoxosulfate is 152 grams and the hexahydrate is 7 into brackets, this is 2 and 16. So therefore we have 152 plus 7 into brackets 18. This will give a total of 7 times 18, which is 126. 152 plus 126. When you add it up, you have 278 gram per moles. So mind you, this is the molar mass of iron 2 tetraoxosulfate 6 hexahydrate that will be used. It is highly important to compare it with the number of moles required or expected. Now, in order to do that, in order to achieve that, from number of moles, which is mass over molar mass, the number of moles is expected to be the same, 0.0362. The mass is unknown. Then the molar mass we got here is 278. When we cross multiply, we have x equals 0.036 times 278. Therefore, the mass that will be required to mix up in 1 dm cube of that very solution of iron 2 tetraoxosulfate hexahydrate is, using your calculator, this will give you 10.06 gram. Now, mind you, the 10.06 gram is the mass that will dissolve in 1 dm cube of the solution. And in 1 dm cube of the solution, we can decide to split our solution into various places. I can decide to take the portion that will be appropriate for 250 centimeter cube or 500 centimeter cube of the solution. Therefore, in order to prepare a smaller mass or a smaller solution, I will use, since 1000 centimeter cube of will require 10.06 gram of FAQS. Therefore, 250 centimeter cube, you can write it to distilled water. Therefore, 250 centimeter cube of distilled water will give how many grams of iron sulfate. So by doing that, this will go up, and therefore you have 250 divided by 1000 times 10.06. So with this, I can prepare a smaller solution that the students would end up using. So this is 250 divided by 1000 times 10.06. So that gives me a value of 2.52 grams in 250 centimeter cube. Aside this, it is also important to know that during the redox titration, we don't really have an acid or a base. In a typical titration setup, here we have the iron sulfate solution, and in the burette we have the potassium permanganate. So this is the oxidizing agent, and this is the reducing agent. I believe with this simple explanation, we should not find it hard to solve questions related to redox titration. And students should get familiar with this because this will help them a lot and it will allow you to develop mental.